Hi everyone, my name is Kritika and I'm back with another video on graphs. So let's dive straight into what exactly graphs are. So this generic structure which you see over here, this one is actually a graph. It consists of basically two things that we must be aware about. So these circular objects that are present, these are called the nodes, and the connectors which we have, these are called the edges. So if any structure consists of these nodes and edges, we call it a graph. So basically there are two types of graph. One is the undirected graph and one is a directed graph. So what is the undirected graph? Basically every node is connected to every other node, but there is no sense of direction over here. We can travel from any node to any other node. So for example, we can go from 1 to 2, then 2 to 3 and then 3 to 5. Or we can also go from 1 to 5 and 5 to 3 and 3 to 2. So there is no particular direction in which we need to travel. However, in a directed graph, there is this arrow. What exactly does this arrow signify? We can, if I'm standing at 2, then from 1 I can go to 2. From 3, if I talk about 3, from 2 I can go to 3, but from 3 I cannot go to 2. So a question might arise, can we have multiple edges? Then that is also true. If we make an edge like this, then this can also be the case. We can go from 1 to 2 and 2 to 1. So yeah, basically in the directed graph, we can only go from one node to another if there is a directed edge present in between. That is called a directed graph. Now that we know about the types of graph and the nodes and vertex, let's look at what are the cycles in a graph. Now you must be wondering that if all graphs are called graphs if they have a cycle in between. So for example, I have this graph with me over here. Now this does not have a cycle, but still this is a graph because the necessary conditions are that it must contain a node, it must contain an edge, both the conditions are satisfied, so this is also a graph. But if we talk about the cycles in the graph, so talking about this undirected graph, let's see, do we have cycles in this graph? Yes, we do. How? We can say that from 1 we can go to 2, 2 to 3 and then 3 to 5 and 5 to 1. So basically we can cover all the nodes through one cycle. Again, we have another cycle from 5 to 3, 3 to 4 and 4 to 5. This is also a cycle. So in the undirected graph, basically we can have multiple cycles. This can also be a cycle in the graph. This can also be a cycle. So we have multiple cycles. So in an undirected graph, if we have cycles present, then we call it a undirected cyclic graph. Now coming to the directed graph. In the directed graph, what happens is a cycle is present only if we are able to form a full circle. So from 1 we can go to 2, 2 we can go to 3, 3 we can go to 4, but from 4 we cannot go to 1. There is no edge which helps us to go from 4 to 1. So there is no cycle present over here. If we see this, then again from 3 we can go to 4, 4 we can go to 5, but from 5 we cannot go to 4. So again there is no cycle present. So since there are no cycles present in this graph, therefore this is called as a directed acyclic graph. In short, we also refer to this as a DAG, which is a very important term. We'll be referring to this in further lectures as well. So now that we know, we have covered the cycles part. So it is not the important points to take away from here are it is not necessary that all graphs contain a cycle. This is also a graph, so it is not necessary. The necessary condition is that it must contain nodes and edges. In the directed graph, we determine the cycle through the edges that we are given to us. So we check the direction and then we are able to determine if a circle is present in the cycle is present in the directed graph or not. And we come to the degrees in a graph. So what is the degree of the graph? In this undirected graph, let's talk about this undirected graph. How do we determine degree? Is by the number of connected edges to a node. So if we talk about this node 1, we can say that the degree of this node 1 is degree of node 1 is 2 because two edges, this one and this edge, two edges are connected to this node 1. Again, if we talk about the degree of node 5, then we can say that the degree of node 5 is 3, right? Coming to this directed acyclic graph, how do we determine the degree of the nodes in this acyclic graph? So that is through the number of incoming and outgoing edges. What do I mean when I say this? For every node, we actually talk about two things. The in degree of node 1. The in degree of node 1 is, see, no incoming edges are there. So therefore in degree of 1 is 0. And out degree of node 1 is 2, because there are two edges which are going out from the node 1. Similarly, we can write for all the other nodes. So the in the undirected graph, it is determined through the number of connected edges, and in the directed graph, it is determined through the in degree and out degree of every particular node. Coming to path, what exactly is a path? Now, if we talk about a path in this same graph which I had drawn previously, so what can be a particular path? What the definition of path? It says that a lot of nodes are present and each of them are reachable. So basically every node is reachable. So for example, I take this path 1, 2, 3, 4. Now this is a valid path. Again, if I take 1, 2, 3, 5, then this is also a valid path. But if I take 1, 2, 3, 2, 1, this is not a valid path, because according to the definition of path, it also says that no node can be repeated twice. So the node cannot come twice in the path. If the node is coming twice, then it is not a valid path. So that is it for the video. I hope you liked it. And if you did understand the concepts, do like, share, and comment down below in the comment section. And let me know if you want me to cover any other topics as well. And if you haven't yet, please do check out the other series that I've already made. The links are available in the description below.